Okay, in this topic, we'll cover operating system structure. This chapter 2. So this is the subtopic that we are going to explore in this chapter, including the services, the interface system call, and the various system call provided by the OS. Then the system program. After that, the design, the structure, and the debugging, and lastly the system boot. Okay, this is the objective of this chapter. We explore the services provided by the OS, the structure, and you should be able by the end of this topic, you should be able to explain how to install and the installation, the customization, and how the OS in terms of boot process. The OS services, there are many services provided by operating systems. The most common services is the user interface. So user interface provided by the OS can be in the form of a command line or CLI, graphical user interface GUI, or even batch. That means it allows the user to do batch processing. The next services provided by the OS is in terms of program execution. It allows the user to execute program. Next, I/O operation. That means if user requests for example, to save or read the data from a file, then the services are provided by the OS as well. Of course, file system manipulation is also provided by the OS. That means the OS allow you to run a program that for writing a file, or to create a new file, or delete, search a file, to list a file, or to read the information of the file. So this kind of services are provided by the OS. So OS also allow communication through network. That means it allow your computer with the system to communicate to other computer. So this communication, especially on a network, is also supported by the OS. Of course, OS also help you to detect error. If there is any error, it should be handled by the OS. Okay, extra services provided by OS. Resource allocation. So this is the services they provided by OS to improve the efficiency of the OS. The efficiency of the computer system. So services in terms of resource allocation, the OS will do the scheduling, appropriate scheduling, so that it makes sure the CPU utilization is optimized. Same thing happen with the main memory usage, and providing the queue to file access and IO devices access. In terms of accounting, OS allow you to keep track the user who are using the computer system, and what kind of resources available to that user. Of course, OS also provide protection and security. That means the OS will make sure any resources, the access to any resources is only available to specific user. So that means one user cannot access other file belong to other users unless that file is set for public access. So in terms of security, users are not allowed to have a direct access to the I/O device, for example. So in order to read or to write to the input output device, it must go through the OS. So any direct access, attempt to direct access is considered invalid by the OS. It's forbidden by the OS. Okay, a view of the OS services. At the bottom level, the lowest level is the hardware, and then you have the OS to handle the communication between the services and the hardware. And then in order for the services between services and the user interface, we have the system call. And at the highest level is the user and the system program. So user and system program can execute any process or program through user interface. The user interface can be a GUI or command line interface or batch command. So this can be executed through system call. So in terms of services, it can be program execution, I/O operation, file system, communication, resource allocation, accounting, error detection, and also protection and security. So what is command line interface? In terms of user interface, in terms of interface, there are three types of interface. Command line interface. This is a very basic user interface where when you want to communicate through to the OS, you simply type the command, and then as long as the command is the syntax of the command is correct, then it should be executed by the OS. And then you need a shell. You need a shell. Shell is the interface or terminal that you use to type in the command. This is an example. For example, this is bourne shell command. This is the terminal for Mac OS. Similar interface for any other Unix-based system, except for Windows, they are slightly different. Windows, they have command prompt. We call it command prompt. Okay, this is the most common. You can communicate to the OS through graphical user interface. Normally, you have to use mouse, keyboard for the entry and monitor for the output. Normally, the program is represented using icon. Windows, for example, the default interface is GUI, but it also supports CLI through command prompt. For other OS, for example, for Mac OS, also the default interface is GUI, Aqua GUI, and then Shell command are also available. Command line interface through shell are also available. Because Apple is actually based on Unix. And lastly, for Unix and Linux, the default interface is command line interface. But nowadays, the GUI interface are very common in Unix and Linux. Another option is touchscreen interface, especially for Android OS, for example. Also, voice command interface are also becoming more common today, especially for handheld devices. Okay, this is an example of Mac OS X GUI, where you can run many programs through the GUI interface. Okay, next section is our subtopic is on system call. Now this is very important. You need to you should understand what the role of system call in the OS. We can say that system call is the heart of any operating system. So basically, system call is simply a programming interface. Programming interface, one of the service provided by the OS. Normally, it is written in C or C++. This system call. It won't be written by using Python or even Java. So it needs a high-level language. Commonly, it is in C. However, if you write your own program, you normally write in a high level API rather than the system call. So there is another level of library, programming library. Normally when you write your own program, you use API, high level API. Even though it is also possible for you to call the system call, to directly invoke a system call in your program, but it is not common unless you are writing a kernel. Depending on the OS that you use, for example Windows, it comes with Windows API. If your system is POSIX based, then it comes with POSIX API. So POSIX based system include Unix, Linux, or even Mac OS X. It is part of POSIX family. Another OS type is Java Virtual Machine. So Java Virtual Machine, they come with Java API. Okay, let's see the system call in action. For example, over here we want to copy, we want to do copy the content of from one file to another file. Let's say you have the source file A, and then the destination file B. So you want to copy the content of file A into file B. So this operation will require many system call. So the sequence is, first you get the input file name and then write prompt to the screen, and then accept the input. Secondly, you also need the file name of the output for the output. And then the third step is to open the input file. So make sure if it doesn't exist, then you can stop the program. Otherwise, continue by creating the output file. If the file is already exists, then terminate the program. And then the next step is to execute the loop to read the input and then write to the output. You need a loop because depending on the mechanism, whether you want to read character by character or word by word, or for certain length of input or chunk of data until the end of a file. So once finished copying the data, close the auto file, and then send the message to the screen that saying the copy process is finished, and then lastly to terminate the program normally. So you need several system call in order to copy source file to the destination file. This is the standard format of standard API. It must have a function name. There are three components: the function name, the parameter, and also the return value. So in terms of parameter, it can have many parameter. For example, for read function, read system call, it needs 3 parameters, but it always return a single value. So the parameter is integer, void, and size t. So this is for read system call. Okay, let's explore the implementation of the system call. So system call interface, it is actually maintained as in a table index. As a user, if you write a program, you do not really need to know how the system call is implemented. What you need to know is the structure of the function call or the system call. For example, this one, you need to know the function name, you need to know the return value, you need to know the format of the parameter. So those are the things that you need to know if you want to invoke a system call. But how it is implemented is not needed by a user that try to write the program to invoke a system call. Okay, this is the relationship between the system call API and the OS. Now when you write your program, you write the user application, so you invoke the open system call. So that system call is actually in a user mode. It means you are only allow to invoke the system call. The actual execution of the system call that involve because open system call that involve IO device, IO operation. So the actual IO operation is executed by the operating system. So that is in kernel mode. So once it is executed, it will return the value. So when user try to communicate to the hardware, it need a system call interface. The user operate in the user mode, while execution in the between the system call and the hardware is what we call in a kernel mode. So user is not allowed to enter kernel mode. The next thing to consider when you invoke a system call is how to send the data. Parameter. Send data through parameter. So there are three methods to pass the parameter to the OS. Okay, of course the simplest one is by simply passing the parameter through register. The second way is by storing the parameter in a block. This is what happened in Linux and Solaris. Solaris is another operating system developed by Sun. Sun is a very big company, but it is no longer operating right now. It no longer exists. The third method is using stack. So there are three methods. So the first option is register. The second option is storing in a block, and the third option is by using stack. Okay, the advantage of the second and the third option, parameter storing through block and the use of stack is there is no limitation in terms of number and length of the parameter to be passed. Whereas for the register, the limitation is you can only pass the data based on the available number of register available in your system. So the size of data that you can pass through register is very limited. Unlike passing through block or stack, there is no limitation. Okay. And okay, how do you pass parameter using block? Okay, this is what happened. Let's say you have a very big data. So instead of copying all the data into a register, because you have a number of register are very limited. So instead of passing the actual data, you simply pass the address of the data in the memory. So this is what happened in the second step. Second method, parameter passing via table. So instead of passing the actual data, you use register to store the address of the actual data. So because the address, the size of the address normally quite small, so register are sufficient to store that address information. So that address will point to the actual data. So this is what happened when you use parameter passing variable. That's why the data, the size of the data is not restricted. There is no limitation in terms of size of data when you use this technique. Now, in terms of type of system call, there are system call for process control. This include the system call to create the process, to manage process, to end and abort the process, to load and execute, to get the attribute of the process, wait for time, memory allocation, and many more control for process. Okay, this is another variant of process control. For example, Arduino is quite simple. For Arduino, you only have a free memory and bootloader section. Because you are in Arduino, you can only execute single tasking process. There is no multitasking process in Arduino. Therefore, operating system is not required. Even user interface is not required. So you as long as you have the bootloader and you have the free memory. So any program that you write, you simply load it into the free memory, and then put that program in some section of the free memory, and the bootloader will directly load the program. Okay. So if you have another program, and then it simply override the existing program in the free memory. So it's a very simple mechanism in Arduino. You only have two sections, the bootloader and the free memory. Okay, for FreeBSD, since FreeBSD allow multitasking, it is a variant of Unix. That means the same mechanism apply for any other Unix variant that include Linux and Mac OS X. So okay, for Unix variant, since it's support multitasking, then the structure of the process is different. You have the kernel, you have the process, you can have process, three process, for example, in here, and then you have the interpreter and you have the free memory. So it's more complex compared to Arduino. System call in terms of file management. So there are also system call that allow you to create a file, delete a file, to open, close, to read and write. There are also system call for device management. That means you can invoke a system call to request and release the device, even to attach and detach the device. There are also system call to maintain, for maintenance. For example, to get the time and date, to set the time and date, and also system call for communication, to create and delete communication, to resend and receive message, and also of course system call for protection. So because these are the role of the services provided by the OS, so each services must have their own system call, their own set of system call. This is an example of system call in Windows and Unix. For example, to create a process in Windows, the function is create process, whereas in Unix the function name is fork. Exiting process in Windows, it is called exit process. In Unix it is called exit. For file manipulation, you have create file for Windows and open for Unix, read file for Windows and read for Unix, and so on. So there are also system call for device manipulation, information maintenance, communication, and protection. So this is the difference between Windows and Unix. Now let's say, okay, normally when you write a program, you don't normally invoke the system call directly. So if you write in C, for example, you have the, instead of using the system call, you use high level programming language, library call. For example, here you use printf instead of write. That is the system call, you use printf. So printf is the library call that you can execute in a user mode. So that printf will be translated to write system call in a kernel mode. So you communicate, or you can invoke the system call indirectly using a standard C library.